Hello everyone, welcome to the world of chemistry. Today we'll continue our discussion with the leftover separating techniques of mixtures. The first technique is separating funnel. Those liquids which do not mix with each other are called immiscible liquids. Example, kerosene and water, oil and water, etc. Immiscible liquids can be separated by using separating funnel. The principle behind is that immiscible liquids separate out layer depending on their densities. So let's see how this method is done. A mixture of oil and water has been taken. It has been poured one by one in the separating funnel. Then the funnel has been shaken vigorously and left for some time without disturbing. After some time we can observe two separated layers. The upper layer is oil and the lower layer is water. Then the tap of separating funnel has been opened. The water has been collected in a beaker followed by oil in another beaker. So this is how we can separate two immiscible liquids by using this method. The next separating technique is fractional distillation. Fractional distillation is the breaking down of a mixture into its component parts. This is done by boiling the mixture and separating the products by their varying boiling points. As the temperature increases, the components with the lower boiling point leaves first. Let's see the process. A mixture of acetone and benzene has been taken. As the difference in the boiling points of acetone and benzene is only 24 Kelvin, the boiling point of acetone is 329 Kelvin and of benzene is 353 Kelvin. So their mixture can be separated by this method using a fractionating column. Let's see how this can be done. The mixture has been taken in the distillation flask. Fractionating column has been inserted between the distillation flask and Liebig's water condenser. The flask is heated on water bath at a steady temperature of 329 Kelvin. Acetone distills out and is collected as first fraction in the receiver. The vapors of benzene are cooled in the column and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out and is collected as second fraction in the receiver. So, by this we can separate two miscible liquids. The next method of separation is chromatography. So what it is? Chromatography is a series of analytical techniques that can be used to separate mixtures of compounds for further use or for analysis. In all forms of chromatography, a mobile phase moves through or across a stationary phase. But what are these two phases? Stationary phase does not move, as the word itself describes. Compounds in the mixture are attracted to it or adsorbed and slowed down. Either a solid or a liquid it can be. Mobile phase. This phase moves. The more soluble compounds in the mixture are carried faster as the mobile phase moves. It can be either a liquid or a gas. Paper chromatography. The chromatography lets us to separate inks and dyes according to the size of their particles. As the solvent or the water rises through the paper, it dissolves the sample of the mixture, which will then travel up the paper. Smaller particles travel farther than the large particles due to the differences in solubility and their attractions with the paper. Let's see how this method works. Does black ink consist of only black color or any other color as well? Let us find out by the process of paper chromatography. Chromatography is a technique of separating two or more dissolved solids which are present in a solution in very small quantities. Take a strip of filter paper. Draw a line with a pencil close to the lower edge of the paper. Put a small drop of ink on the center of the line. Let it dry for some time. Take a jar containing some water. Put the filter paper in it such that drop of ink is just above the water level. Put the filter paper in it as shown. After some time, the water starts gradually rising up by capillary action. It is the movement of a liquid through or along another material against an opposing force such as gravity. Example, moving water up a straw or glass tube, or moving of water through a paper or cloth towel. As the water moves up, it takes dyes present in the ink along with it. As the water rises up, we see different colors on paper. These are the different dyes present in the ink. Different dyes have different solubility level and travels at different speeds as the water rises up. As a result, we see different colored stripes at different heights and the dyes get separated. Hence, paper chromatography is used to separate the different colors in a dye. Students, I hope you understood this chapter well. Thank you.